In this video, we're going to work on a circular motion problem on a vertical loop. A classic scenario for this is a roller coaster. Here we have a roller coaster car zooming along the bottom of the track. We are given the normal force, which is Fn. It is 3.5 times of the weight. Okay, so the weight is the gravitational force, Fg. So we have Fn is 3.5 times of Fg. We are also given the speed is 26 meter per second. So we have v is 26 meter per second. We need to find the radius of the track. So what is the radius of the track? In uniform circular motion, what connects the radius and the speed is the centripetal acceleration, AC, which can be expressed as v squared over r. Or we multiply this centripetal acceleration by the mass m, we get the centripetal force Fc, and it equals to mv squared over r. As soon as we find the centripetal force, we can easily calculate the radius. We know the centripetal force Fc is actually the net force exerted on the car, F net. So let's quickly draw a free body diagram to figure out what the net force is. There are only two forces acting on the car. One is at the bottom of the track. First, we have the gravitational force, Fg, pulling down. And second, we have the normal force, Fn, that is supporting this roller coaster car. Don't draw the centripetal force on this free body diagram. Centripetal force is not a fundamental force. It's simply the net force that is working to change the direction of the velocity, making the car move in that circular loop. Okay, so the net force is the subtraction of Fn and Fg. So we have Fnet equals to Fn minus Fg. We know Fn is 3.5 times Fg, then minus Fg. Eventually we have Fnet is 2.5 times of Fg. Now you see that we have the centripetal force, which is 2.5 times Fg. And this centripetal force is pointing towards the center of the loop, which will make the car move in that circular loop. So now let's replace Fc as mv squared over r. It equals to 2.5. The gravitational force Fg is the m multiplied by the gravitational acceleration g. Now you see we can cancel the mass m on both sides. To isolate r, we multiply r on both sides. So we have v squared equals to 2.5 gr. And then we divide 2.5 g on both sides. We have v squared over 2.5 g equals to r. So r is v squared over 2.5 g. So as the last step, let's plug in the values. The speed is 26 meter per second, then squared, divided by 2.5 times 9.8 meter per second squared. So r, or the radius of the track, is 27.6 meter.